The kinetic molecular theory is quite a lengthy word and sounds pretty fancy too, but this is a pretty important model to understand, and it will reveal a lot about what we currently know about the three states of matter. So in this video, we will go over what the theory is, how we see temperature and energy, and how it applies to matter around us. To begin, let's break down the kinetic molecular theory, which sounds like a very fancy thing, but it's actually quite simple. There are four main points to consider in this theory. First, all matter is made of smaller particles, namely atoms. Second, there's always empty space between those said particles. Third, those particles are constantly moving. And lastly, more energy, or having a higher temperature, makes those particles move faster. This is a pretty interesting point, as we need to think about temperature differently. Temperature is essentially how much energy there is, or in other words, how fast a particle is moving. So, on a hot summer day, when there is a higher temperature, we will feel more hot because there is more energy, and the air atoms are moving around a lot faster than the air atoms during a cold winter day. Now, all this movement is considered kinetic energy, which is the energy of motion, hence the name kinetic molecular theory. And this theory tells us how different matter behave based on how much kinetic energy it has. With that being said, let's talk about how we apply this theory to the real world by going over the three states of matter: solid, liquid, and gas. And in this example, we'll be using an ice cube, some water, and some water vapor. Starting with the ice cube, it is definitely made of particles, and even though those particles are very tightly packed together, there is still empty spacing between them. Since an ice cube is quite cold or has a lower temperature, it has lower energy. This means that the ice cube particles are moving much, so they just vibrate in place. Now, if we turn the temperature up or increase the ice cube's energy, it melts into water. Now that it has a higher energy, the particles that make up this puddle of water are now moving faster, to the point where they slip and slide past one another. Obviously, this leaves a lot of space in between those water particles. And lastly, if we increase the temperature even further, or add more energy until the water evaporates into water vapor, the particles that make up the water vapor are now moving even faster. They are moving so quickly now that the gas has started spreading out and leaving tons of empty space in between those water vapor particles. Another interesting observation is that a solid will always stay in the same shape, a liquid will take the shape of whatever container it is, containing it, and a gas will diffuse and fill up whatever container. And there we have it. The kinetic molecular theory describes matter based on how much kinetic energy or motion energy it has. The lower the energy of a matter, the lower temperature it will have, and so, the slower this matter's particles will move. In a solid, or the state with the lowest kinetic energy, the particles are merely vibrating and non-moving. In a liquid, the particles are sliding and moving around, and in a gas, the particles are very quickly flying around. So, the next time you drink hot tea, think of it as drinking water molecules that are moving faster than the water molecules in cold tea. I hope that y'all learned something interesting today. Thank you for watching, and good luck with everything.